Hey everyone, Johnny here and welcome to another video. Today we're going to be looking at how to find a missing side or a missing angle in a right-angled triangle, or as some call it, a right triangle. That is simply a triangle that has a 90-degree angle in it, typically represented by a box, like you can see here, but not always. Sometimes you will simply be told that the angle there is 90 degrees, and you can then draw in a box if it makes it easier for you. Or you will be given some other information which you have to use to then find that one of the angles in the triangle is 90 degrees. And then you proceed from there. Okay, but before we do that, please do me a favor, and if you haven't already, subscribe to the channel and click the bell so you are notified of our future videos. And if you enjoyed the video, please like and comment below. Okay, so how do you find a missing side of a right-angled triangle? Well, the first question actually is a step before this. It is the step 0, as I like to say, okay? Step 0 here is always ask yourself when you get given a trig question, right? Trig, short for trigonometry, a question on triangles, what type of triangle you're dealing with. Because we're assuming here that this is a right-angled triangle. But that's the first question you should always ask yourself, which might sound silly. You might think it goes without saying that it's right-angled. But sometimes you will be asked to find a missing side or a missing angle of a triangle that isn't a right-angled triangle. It doesn't have 90 degrees inside. And in that case, you would actually use two different methods to the ones I'm going to show you here. So if you are given a question that actually gives you a non-right-angled triangle, I'll just put non-right triangle for short, make sure that you don't then use the methods I'm about to show you. So if you are going to find a missing side or a missing angle of a triangle, you first ask yourself, is it a right-angled triangle or a non-right-angled triangle? If it's a non-right-angled triangle, so it doesn't have 90 degrees inside, the two methods you want to be familiar with, the two options that you have, which we'll look at in another video, are the sine rule and the cosine rule. So one of those will be useful for you. It will depend on the information you are given as to which one you use, but one of those will help you find the missing side or missing angle for a triangle that doesn't have a right angle. But if it does have a right angle, you're going to use the methods I'm going to show you now. But always ask yourself, the very first question, is it a right angled triangle or not? If it is, we proceed as follows. If you are finding a missing side, there are two possible formulas that you might have to use. Okay, and here are the two. The first one is one you should be familiar with, but if you're not, you can look at our other videos on this, is Pythag, or Pythagoras' theorem. Okay, I just say Pythag for short. So you can use Pythag to find a missing side where you are given the two other sides. So see in this first situation where I have a triangle where I get 3 and 4, well, if I want to find that third side, I have to use Pythag. So you use Pythag when you are given two sides and no angles. So you're not given any angles except, of course, the 90-degree angle, which makes it a right-angled triangle. So if you were given no angles and two sides, to find the missing third side, you use Pythagoras, which we'll do in a second. If you are given one side and you need to find another side, and then you're given another angle, so an angle and a side, you are going to use a method or an acronym called SOHCAHTOA. Okay, sounds funny, but it's a good way of remembering what to do. SOHCAHTOA, I'll explain that very shortly. Okay, SOHCAHTOA is going to be also what you use to find a missing angle. Pythagoras won't help you find a missing angle directly. So SOHCAHTOA and Pythag for a missing side, and just SOHCAHTOA for a missing angle. Okay, so let's go into what these mean and how to apply them to a question. Okay, so for the first situation, you can see here we have the situation of two sides and no angles. It's not a situation where we have one side plus one angle. Okay, that's when you would use SOHCAHTOA. So we are going to use Pythag. Okay, what is Pythagoras' theorem? Okay, Pythagoras' theorem is simply that the hypotenuse, that is, the side that is opposite, directly opposite the 90-degree angle, so you can just draw a diagonal from that box there, that's this side here, c squared, we call it c, I know here it's x, but the general formula is c squared, will equal, remember, c is the hypotenuse. It's the longest side of the triangle, which is opposite the 90-degree angle. Okay, that is the hypotenuse. It's called the hypotenuse. It's the longest side, and it is opposite the right angle. And that side squared, not that side exactly, that side squared will equal the square of the two other sides added together. Or rather, it will equal a squared plus b squared. It will equal the square of the first side plus the square of the other side. So these two ones here are called the short sides. It doesn't matter which one represents A or B. So these are the short sides, 3 and 4, because they are not opposite the right angle. Okay, so if you want to find the longer side, the hypotenuse, then you have to insert that here where the C is, okay? If you were trying to find this side here, the short side, so pretend we were given X there and we didn't know this side here where the 3 is, then we would actually rearrange the formula. I'll just show you the other way of writing the formula. This is to find a short side, such as where 3 is. If I wanted to find this side here, we would actually rearrange this formula so that we move the b squared to the other side so that we just have a squared by itself. So imagine we wanted to get rid of b squared from the right-hand side. How do you get rid of b squared? You do the opposite. You would subtract b squared from both sides, because what you do to one side, you have to do to the other to make it even. Therefore, you're allowed to do that. And you would be left with c squared minus b squared equals a squared. Or, I'll just reverse the order there, a squared equals c squared minus b squared. So that's another version of the formula of Pythag that you could use if you were trying to find a short side. But in the example I've given here, you're not trying to find a missing short side. You're trying to find a missing hypotenuse because it's the longer side, as I've said. So we will use this version of the formula. But just note there are two versions of the formula. This one you can use, which comes from the same formula. Okay, so they're not really two different formulas. They're just different ways of writing it to be more efficient. Okay, if you only use this one formula, you could still get to the answer for a short side. It would just take you an extra step. This is just saving you one step because we've already moved the b squared, the other short side, to the other side of the equation. Okay, so here let's apply this formula. Remember, c is the hypotenuse, so in our case that is x. So we have x squared equals 3 squared. Remember, I could have written 4 squared first. It doesn't matter which one represents a and b. And we get x squared equals 3 squared plus 4 squared. Now 3 squared equals 9 plus 16. So we get 9 plus 16. That is 25. Okay. So x squared equals 25. Okay. Because 3 squared is 9. 4 squared is 16. Now x squared equals 25. That's not our final answer because we only know what x squared is. We don't know what x is. We don't want to find the square. We want to find just x. But because the formula finds you the square of it, you always have to square root at the end. Because square rooting is the opposite of squaring, and so that will help you cancel out the square. But of course, what you do to one side, you have to do to the other. So we'll square root the x squared to get rid of that squared, but we also then have to square root the 25, and that will lead us to x equals 5. Okay, so x equals 5, that's our answer by using Pythagoras' theorem. Okay, what about where you're finding a missing side where you're given one side and one angle? Well, we don't use Pythag. Pythag is no good to us unless we know the two other sides, such as in this example. Here, because you're given an angle and a side, we use a method called SOHCAHTOA. Now let me explain SOHCAHTOA briefly. The first thing we write here is SOHCAHTOA because we know, firstly, it's a right-angled triangle. And secondly, we're given a side and an angle. Okay, so they're the two requirements. Remember, always ask yourself, is it a right-angled triangle when you start any of these questions? Okay, SOHCAHTOA, what does this actually mean? This is basically a helpful acronym, right? It's like a way of remembering what to do when you're in this situation. So SOHCAHTOA, and it's important to say that out loud to yourself a few times, is basically representing sine, S for sine, and I'll just put here sine, C for cos, and T for tan. They're the three different trig identities that you might have to use for a right-angled triangle, okay? And you'll see those on your calculator. You'll see sine, cos, and tan. Or it's technically cosine, but cos for short. And what we want to do here is they're actually in groups of 3. So when you say SOHCAHTOA, the reason we're starting with the S, then the C, then the T when we say that in each syllable, like so, then ka, then toa, right? The reason we do that is so you can separate them, okay? So when you have sine, if you were going to use sine in this problem, you are then going to concentrate on the opposite side to the angle you're given and the hypotenuse. And what you're going to do is you're going to divide the opposite side by the hypotenuse. If you have to use cosine in your calculator, the way to actually work out the equation will be to get the adjacent side and divide it by the hypotenuse. So O represents the opposite side, H represents the hypotenuse, and A represents the adjacent. But understand you have to divide the first letter by the second letter after sine, cos, or tan. So if you're doing tan, you are going to do opposite over adjacent. Now, what I just said might not make sense if you're new to this. Let me show you it in an example. Okay, so when we use sine, cos, or tan, you always have to put an angle next to it, otherwise it has no value. So sine, cos, and tan are not numbers. They are only values when they are paired with an angle. Okay, they are ratios. They will tell you a ratio, but more on that in a different video. So let's say you're in this situation here. How do you do this question? If I want to find the missing side here, A, okay, it could be A, it could be X, it could be Y. It doesn't matter what the symbol is, what the pronumeral is. If I want to find that, the first thing I do is I go to my angle here, the angle that's not 90 degrees, of course, which is 30 degrees, and I draw a line here. And I can see that the A, the side here, is opposite. It is the opposite side to the angle I'm given. So you start at the angle you're given and draw a line, and if the line goes to the opposite side, which of course isn't the hypotenuse, then it is called the opposite. Okay, it is O for opposite. And then the other piece of information you have, so we're just seeing what information we are given here, is we are given the hypotenuse. Okay, you're given the hypotenuse because look, the side here that you're given 12 is directly opposite that right angle. Remember, you can just draw the line from the corner of the box. So you're given the opposite and the hypotenuse. You're not given the adjacent. And the adjacent is this side here because have a look, that's the other side that I could draw in connection with this angle 30 degrees that's directly next to it. Adjacent means next to, okay? The word adjacent means next to. And it is next to it, but you're not given the adjacent here, okay? We don't know that side. All we know is the side that's opposite the 30-degree angle and the side that's opposite the right angle. So because we know the O and the H, have a look. We see O and H. Now, you pair those up. You actually find out what they pair with in SOHCAHTOA. So which one of those 3 sounds has the O and the H in it? So, O and H, there it is. It doesn't work with R or TOA because we don't know the adjacent side. So that pair doesn't work. So you can see here that sine is the relevant identity, the relevant trig ratio, we call them, to apply. So you go to your calculator now and you write sine, or rather you write this down first before you calculate, but you are going to write sine followed by the angle. You always have to have an angle with sine, cos, or tan. Okay, otherwise it doesn't have any value. So sine 30 is going to equal, so this is basically, hopefully you can see now, is a direction for how to write the equation. So if it says so, what it's really saying is sine of the angle, in this case 30 degrees, equals, there's actually an equals there, the opposite side divided by the hypotenuse. And what is our opposite and hypotenuse in this case? Well, sine 30 is going to equal the opposite, which is A. It's, of course, you're not going to know one of them, but that's the opposite. You're basically given that piece of information as being relevant. And then the other piece of information you were given was the hypotenuse, which goes on the bottom. So you can see it's called a ratio because a ratio can also be written as a fraction. That's why they call them trig ratios. Because when you write sine, cos, or tan, you're really referring to a fraction where one side is dividing by another side. And in this case, if you're finding sine, you're talking about the opposite side divided by the hypotenuse. If we were going to use cos, because we were given the adjacent side and the hypotenuse, we would write cos 30 equals whatever the adjacent side was, divided by 12, the hypotenuse. So this would be cos equals, and this would be tan equals. So hopefully you can see here, SOHCAHTOA is telling you how to write the equation when you get given the information. Okay, how do we go from here to solve this? We need to find A. Well, we want to get A by itself. Well, what's stopping A from being by itself? It's A divided by 12, so it's being divided by 12. Well, I want to get rid of divided by 12. How do you get rid of that? You do the opposite of what's happening. So you multiply by 12, because that creates this cancellation, because they're diagonal to each other. There's an invisible over 1 there. What you do to one side, though, you have to do to the other side, so it balances. Otherwise, you're just changing the whole thing. We're not trying to change the value, we're just trying to rewrite it. So we're left with A equals 12 times sine 30. 12 times, make sure you put the times in your calculator. And then when you put that in your calculator, you will get A equals 6. Okay, so the length of A is 6. We now know that using SOHCAHTOA. Let's go to missing angle. So how do you find a missing angle? Well, we don't use Pythag. Remember, Pythag's only when you get given two sides and you're finding the third side. When you're finding a missing side and you're given one angle or one side, or you're just finding a missing angle and you're given two sides, you use SOHCAHTOA. That's what I just showed you. So more practice now to help you understand it. So even though we're given two sides here, you don't use Pythag because we're not trying to find the third side. Okay, so remember, Pythag is like the one exception for when you have two sides and you're finding the third side, whereas SOHCAHTOA is what you'll use in all of the other situations when you have a right-angled triangle, but not when you have a non-right-angled triangle, okay? Not when you have a triangle that doesn't have 90 degrees. So, how do you find a missing angle? Well, we first of all start by looking at our triangle and looking at the angle we're trying to find. So here it's called theta, okay? That's just the symbol, theta. It's like a Q, and often you'll see that, but it could be A or X or Y or any letter, as I said. What we then do is we have to determine what sides we are given relative to this angle. So I start my pen, or my text in this case, at the angle. It's always good to just put the pen on it in the diagram. Make sure you always draw a big diagram in these exams. And then what you want to do is figure out what sides you're given relative to it. So am I given the opposite? No, because I would have had to draw the line all the way over here, but I'm not given the opposite. What I'm given here is the side that is directly next to it. It is the side adjacent to the angle. It's not the hypotenuse because it's not opposite this box here like the 16 is, but what it is it's the side which attaches to the angle we're trying to find, and it's next to it, so it is the adjacent. So we're given the adjacent here. What we're also given, and you might say, well, isn't the 16 also adjacent? Because look, the 16 is technically next to the angle. Well, yes, it is, but because it's also opposite the right-angled box here, the right angle, the box points to the hypotenuse, the longest side of the triangle, it is not called the adjacent, it's just called the hypotenuse. So have a look here. We're given the adjacent and the hypotenuse. Now sound those out. R, A, H. Go and look at our SOHCAHTOA. Which one stood out there? Well, remember, we are given the A and the H, and I can see A and H here. And that means that we are dealing with cos, because CA is short for cos equals adjacent over hypotenuse. So remember, CA, what does that actually mean? It means cos of an angle equals the adjacent side divided by the hypotenuse. Remember, there's like a division, and it's important that you get the order correct. Okay, it is always the first letter, in this case A, divided by the second letter. So we are going to divide the side that was adjacent by the side that was the hypotenuse to help find cos theta. So cos theta in this case is going to equal adjacent, which is 8, over hypotenuse, which is 16. We can then simplify that to a half. So I'm going to rewrite it. Always good to just line up the equal signs as you proceed through. We basically are left with cos theta equals a half. But that hasn't found us theta. I don't know what the missing angle is. All I know right now is what cos of the missing angle is. So how do I get rid of cos? Well, the mistake a lot of people make here is that they divide by cos. But remember, cos isn't a number. This isn't like saying 5 times theta, where you can then divide by 5 to get rid of the 5. Cos is not a number. It is only a number when it is paired with an angle. So we have a special process for this. It's called doing the inverse. You do the inverse. So we're going to do inverse cos. And in your calculator, the way you do that is you hit shift, you press shift, and then you press cos. And what you're going to see happen is the cos is going to move to the other side with a -1 above it. So we're actually going to get rid of cos by doing inverse cos. So it goes over the top. It doesn't divide off. And what that's going to look like in your calculator, if you hit shift and cos, is it's going to create that. It's going to do cos to the power of -1. That just simply means inverse cos. Inverse cos is cos to the -1. And then in brackets, you put whatever was already on the other side. You put everything on that other side, which was a half. So try do that a couple of times so you get comfortable with that. If you want to get rid of cos, you hit shift cos in your calculator, which is inverse cos. You don't divide by cos because that doesn't make sense because cos isn't a number. And then put that all into your calculator with brackets around the half because whatever was on this other side goes in the brackets. And then when you put that in your calculator, it should give you 60 degrees. So 60 is your answer. And make sure that you press the degrees button on your calculator. You don't want to give an angle as a decimal. So if this happened to be 60.5 as a decimal, it's only 60 degrees in this case, but if it was 60.5, you would press the angle button. Okay, you would press the angle button. Looks something like this. Right, the button that converts the decimal to degrees, and then 60.5 would come up as 60 degrees and 30 minutes. Okay, so 60 degrees and 30 minutes is the same as 60.5. So you can convert from a decimal to degrees and minutes. Minutes sounds funny because it's to do with time, but it's also used for angles. Okay, so just be familiar with those buttons on your calculator. And we can then do as practice our very last question here. I'm going to do this one a bit quicker. I want to find theta. Well, again, how do we do it? We start with theta. We now look at the sides that we know relative. Well, first of all, I notice that I don't know the hypotenuse. See, you can always look at the side that is opposite the right angle. Here, I don't know what it is. So I go back to my angle and I pair it up with both sides. And I say, oh, look, the 7 here is adjacent. It's next to it. It's connected. The side is right there next to the angle. So I know the adjacent. And then this other one, because I've drawn this arrow across, it clearly is the opposite side. And again, I note that I don't know the hypotenuse. So I get the adjacent and the opposite. And I have to now figure out which pair of letters here matches. Well, I know OA is O and A and SOHCAHTOA. So because the O and the A is there, it's telling me to use tan. Okay, so I'm going to write tan theta equals opposite over adjacent. Again, always important to do it in the right order. In this case, the opposite and the adjacent happen to be the same, but they won't always. And that's going to equal 7 over 7. Okay, it's going to equal 7 over 7. And then to find theta, okay, to find the angle, and we can simplify that, sorry, 7 over 7 is 1 over 1, which is just 1. So we end up with tan theta equals 1. Okay, so we're coming over here now. And then what's the last step we do is we press shift tan in our calculator to do theta equals tan inverse bracket 1, because 1 was the number on the other side. That's how you move tan over. You don't divide by tan. You do inverse tan. And then you're going to get theta equals 45 degrees. Okay, always give your answer in degrees when you're finding an angle. So we get 45 degrees there as the answer. Okay, hopefully that makes sense. That is how you can find a missing side or a missing angle for any right-angled triangle. Remember to always pay attention to the information you're given with the question. For example, if you're given 2 sides and you're finding the third side, you'll use Pythag. Otherwise, you're using SOHCAHTOA. Watch this again to get familiar with how to use SOHCAHTOA if you're not already familiar. Otherwise, please like, subscribe, hit the bell if you enjoyed the video, and I'll see you in the next one.